Hello and welcome to Chemistry Nuggets, where you can polish your knowledge and clear your doubts. Friends, today's video is part 8 of Thermodynamics class 11. In this part, we will going to study about enthalpy. Yes, a new term, a new state function. So let's get started. Enthalpy, which is denoted by capital H. So what is the need of enthalpy? Actually, till now what we studied, the process is carried out at constant volume or in the closed container. Closed container means constant volume, or at isothermal processes, that is with the constant temperature. We never talk about the pressure. But in the real life situations, in the labs, what we are doing, that we have the apparatus which are without lids, like test tubes. So it means volume is not constant. At that same time, we are giving the temperature, raising the temperature, lowering the temperature. So temperature may also varies. But what is fixed over here in the real life? The pressure. Pressure remains always constant, and that we can say atmospheric pressure. So when there is a fixed pressure, we need some change in the what we have the equation we have till now with the energy. We have to do some simple change. Let's see how to do. As we know, first law of thermodynamics, delta U is equal to Q plus W, where delta U is the change in internal energy, Q is the heat absorbed at constant volume, and W is the work done by the system. Okay, if we change Q with the QP, which is heat absorbed at constant pressure, because we are going to talk about constant pressure, not constant volume. W is work done by the system, that is minus P delta V. So let's put these values in the first law. So we will get delta U is equal to QP minus P delta V. So delta U we can write U2 minus U1 is equal to QP minus P V2 minus V1. So let's rearrange the whole equation. We can get QP is equal to U2 minus U1 plus P V2 minus P V1. So let's bring the two terms together. We will get U2 plus P V2 minus U1 plus P V1. Correct? This is equal to QP. Now here the term U plus PV, that will be denoted by H. Here comes, we introduce a new term H, enthalpy, which is equal to U plus PV. And from here onwards, we can write QP is equal to, now H2 minus H1. U2 plus PV2 is H2 and U1 plus PV1 is H1. And now we can write QP is equal to delta H. Correct? We can, yes. H2 minus H1, it means change in enthalpy. So now we get change in enthalpy is equal to heat absorbed at constant pressure. So let's check some of its properties. Now enthalpy is a state function. Why? Because it depends on internal energy, pressure, volume. Those are also state functions. So we can write H is equal to state function. We already studied in our older parts that Q, that is heat absorbed at constant volume, is a path function. But here QP, that is heat absorbed at constant pressure, is a state function. Because we know that H is equal to U plus PV and delta H is equal to delta H is equal to QP, that is QP is equal to change in enthalpy. If enthalpy is state function, then QP is also become state function. So now we can define change in enthalpy is equal to the heat transfer at constant pressure, that is QP. Clear? Now one more thing we need to understand, that H is equal to U plus PV. We got it? So we can write delta H is equal to delta U plus delta PV. Yes, we can write, but there is a loophole. Since we took P at constant, so at constant pressure, delta P won't be there. It means there will be P will be constant. There is no change in pressure. So we can write finally delta H is equal to delta U plus P delta V. And now here comes a formula for change in enthalpy is equal to change in internal energy plus P delta V. So friends, here we get a formula for change in enthalpy. Now come up to the sign conventions. That is important when we are doing numericals. So enthalpy is taken negative. When it will be taken negative? When the reaction is exothermic. It means, exothermic means heat is evolved. When heat is evolved, it means there is a less heat inside. So the enthalpy will be negative here. Enthalpy will be positive when the reaction is endothermic. It means heat is absorbed by the system. So obviously when heat is absorbed, it means there is an increase in energy, and that increase makes the enthalpy positive. So friends, now come up to the next very important point. We studied that delta H is equal to delta U plus P delta V. But when we studied practically, we saw that in case of solids and liquids, when the process goes on, there is very less, or we can say negligible change in volume. We found that. So if there is a negligible change in volume, only in case of solid, liquid, or liquid we are talking about. So that whole term P delta V become negligible. So in that case, delta H is equal to delta U. It means change in enthalpy is equal to change in internal energy in case of solids and liquids. Clear up? So whatever the enthalpy change, same is the internal energy change. Now this is about solids and liquids, but in case of gases, there is a huge difference. If there is a slight change in something happens, there is a huge difference in the volume we have seen easily for gases. So in that case, there will be a little different situation. Let's see if there is a reaction. Gas A is the reactant and gas B is the product. So this change occurs only when the reactants and products all are gases. So what will happen? Let's see. So let's take total volume of the gaseous reactants will be VA. Total volume of gaseous product we will assume VB. Number of moles of gaseous reactants, it will be Na, and number of moles of gaseous products we will assume NB. So as we are talking about gases, so at constant pressure and temperature, ideal gas law is PV is equal to nRT. So let's put the values here. We can write for reactants PVA is equal to nART. For product part, we can write PVB is equal to nBRT. Now if we take both the reactions together, PVA minus Let's take both the reactions together. We can write PVB minus PVA is equal to NBRT minus NART. or rearranging this, we can get P VB minus VA, NB minus NA, RT. So we can write P delta V is equal to delta N RT, or more precise way we can write P delta V is equal to delta NG RT. Just G is to mention that this is only for gases, nothing else. So G means for gases only. Now let's substitute the value of P delta V in our enthalpy. So delta H is equal to delta U plus P delta V. We already got this. So we can write delta H is equal to delta U plus delta NGRT. And now this we have a new formula which will be applied only for gases. So we can write it here, only for gases. So friends, in this way we understand what is enthalpy, and for gases its value, its formula is different. For solids and liquids, it's almost equal to the change in internal energy. So friends, that's all for today in this video. This enthalpy is very important for the numerical point of view. So till then, for the next coming video, let's wait for 1 week, and don't forget to subscribe the channel. Till then, thank you. Bye.